Alright, we'll take a look at function composition. This is not arithmetic of functions. It's a different sort of operation on functions, and it takes some practice to get used to. What we're going to do is we're going to take two given functions and we're going to create a new function. Okay, so let's make up a couple of functions. So here I've just randomly created two functions, f of x and g of x, and we're going to look at the composition of those functions. So the names of each of these functions are f and g. The function we're going to create is the composition function, which is written f circle g. It looks kind of like fog. Or we could even look at g circle f, or you could even look at f circle f. So f composed with g, g composed with f, f composed with f. Or they could also be read as f of g, g of f, f of f. Okay, so these are the names of these functions we'll look at. You can compose functions in all sorts of ways. Now, what does it mean to compose a function? So I need to feed it an input, let's say x. F of g of x. That's how you read this. And the literal definition of this is f of g of x. So f of g of x. So notice I wrote the guy inside here smaller to fit inside these parentheses, sort of to separate the two sets of parentheses so I don't get confused. So what this means is I need to figure out, I need to work from the inside out. I need to look at g of x first, okay? So if I look at g of x first, I'm just going to copy f of, and I'm going to put my g of x inside. So g of x is x squared minus 4. I go to the definitions of the functions, which are up at the top. These are how these functions are built. These are what these functions are. So I have f of x squared minus 4, and all I did was replace g of x with its output, x squared minus 4. Okay? Now I need to take x squared minus 4 as the input to my f function, which the definition is given up here. So I need to replace all my inputs in the f function with x squared minus 4. So I need to replace this input with x squared minus 4. So I have 2 minus x squared minus 4. And now I simplify this by distributing my negative. So I've got a negative x squared. I've got positive 2 plus 4, that's positive 6. So this is the output for f of g. Okay? We could similarly do g of f of x, which I'll rewrite as g of f of x. I'll look for f of x first, so I'll copy my g of. F of x is 2 minus x. So now I'm going to take 2 minus x and give that as my input to the g function. So I'm going to replace this x in the g function with 2 minus x. So I have 2 minus x squared minus 4. And now I need to simplify that. 2 minus x squared is 2 minus x times 2 minus x. And now if I multiply all this out, multiply the 2 through both and the negative x through both, I end up with x squared minus 4x plus 4. Then I need to bring down to my minus 4 and combine like terms. The positive 4 and negative 4 are 0, so I simply get x squared minus 4x. And that's the output for g of f of x. Now let's look at composing f with itself. We'll look at f of x, and so that means f of x. So I'll copy my f of on the outside and work on the inside, which is f of x. So I'll take 2 minus x and put it in here. And now I'm going to feed 2 minus x to my f function as the input. So I'm going to replace this x with this input 2 minus x. So I have 2 minus x. Now I distribute my negative and simplify. And I get a positive x, and 2 minus 2 is 0. So I simply get x as the output of my f of f function. And that's composition. Okay? You could compose more than 2 functions. You could compose 3 or 4 functions as well. It's the same process, just work from the inside out. You could also feed an input to this that is not a variable. It could be a number. So you'd plug 2 in, and instead of f of x, you'd have f of 2. And you'd continue to plug in the numbers the same exact way.